Hey guys, we're going to go over section 5.2, which deals with electron configuration. We're going to do two different videos that are going to be short on this, just to keep it separated. We're going to go over the basic parts of electron configuration in part one, and then we're going to actually write the electron configurations and orbital notation in part two. Okay, so I'm going to try to keep both videos short. So let's get started here. Okay, so electron configuration is basically like the address for each element. It lets us know how many electrons each element has and where each electron is sitting. So electron configuration is the ways in which electrons are arranged in various orbitals around the nuclei of atoms. Okay, now there's a term called ground state. We're going to talk about it now, forget it, and we're going to come back to it. Okay, ground state is the lowest energy arrangement of the electrons for each element. Now, an example of this would be like taking a piece of iron, holding the iron. It is at ground state. When you heat up the iron, it goes to a different state, and that state is called the excited state. Okay, so we're going to definitely work with that down the road. Now, an example of electron configuration is with this example right here. Now, what do we have here? We have a number in front, we have the letter, and an exponent. Then we have a number in front, letter, exponent. And it repeats itself from left to right. Each one of these is a specific sublevel, all right? And you have the number of electrons at the top. So let's look at the different portions here. Now, the coefficients are essentially indicate the principal energy levels containing electrons. Okay, so coefficients are the numbers in front, like the 1, 2, 2, 3, and 3. Okay, so in this example, there are electrons occupied in the first energy level, electrons in the second energy level, and electrons in the third energy level. The S, P, D, and F that are written include the occupied sublevels. So we have the S sublevel, P sublevel, S sublevel, and P sublevel. So you have your sublevels, and the number up top is what we call the exponents, and that identifies the number of electrons found in each sublevel. So we can think of it as this. So this exponent here, 2, tells us there's 2 electrons found in this 1s. Okay, and the same thing for this 2. This 2 means there's 2 electrons found in this s. Now there's a 6 right here. It's a lot more. 6 electrons found in this p. Okay, and here's a 2. There's 2 electrons found in this 1s, and there's 6 electrons found in that p. Okay, so that's an example of what an electron configuration is. I like to show you one before we get into it so you kind of know what you're going to be building. Now, another important aspect is if you add all of these exponents up, okay, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. Okay, this is very important. This tells us that this is actually a noble gas. This is argon. Okay, so that's a little trick you can keep in the back of your mind. Now, here is a table, which I will also attach, and you guys should see this and look at it. This tells you where the elements lie and the last portion of the electron configuration. Like argon ended in 3p6, and here it is, 3p6. So this table identifies the last portion of the electron configuration. Now, there's 3 very important rules of electron configurations that you must follow before you write them. Okay? Now, the first rule is the Aufbau principle. What does this mean? Well, it's a very important rule, and it's the reason why we have certain sublevels in specific orders. It deals with how the electrons are arranged around the atom. And as you add electrons, the cloud gets bigger and bigger and bigger, and where are they going to sit? Well, based on the Aufbau principle, there's going to be orbitals that the electrons are going to sit in. So let's take a look. So Aufbau principle is where electrons occupy the orbitals of lowest energy first, ground state. Okay, so here we have this Aufbau diagram, which is in all your textbooks. Okay, so now we have at the lowest energy level, this is ground state, all the way at the bottom. Okay, we have the first energy level, second energy level, and in the second energy level there's an S and a P. In the third energy level there's a S, P, and a D. In the fourth energy level there's a S, P, D, and F. Now, as you go down the periodic table, you're going to go through these energy levels. So the first energy level you're going to go through is the 1s, then the 2s, then the 2p, then the 3s. And they're increasing with energy. Okay, the potential energy is rising as you go away from the nucleus. The 3p, 4s, 3d comes after 4s, then 4p, then 5s, then 4d, then 5p, okay, and 6s, 4f, 5d, 6p. Okay, so at the bottom here, I have a list of the order that you need to know up to 5s. I mean, any further, it's pretty far. We're not going to be really going past 5s for the most part. Okay, so we have our first energy level, 1s, here, 1s. Then we have 2s, 2s. Then we have the 2p, which is 2p. Then we go to 3s. Okay. Now notice for every s, there's one box or one line. That's an orbital. P's have 3 orbitals. So there's one line for the s, one line for the s, 3 lines for the p. One line for the s, 3 lines for the p. And then 3p is the next one. Then after 3p, you go to 4s. Okay, 4s has 1 orbital, or 1 line. Then after 4s, you go to 3d. And here it is, 3d. But 3d doesn't have 3, it doesn't have 1, it has 5. 1, 2, 3, 4, 5. So the d can hold 10 electrons. Okay. Then you have the 4p. Right here, 4p. 4p has the 3 orbitals, 1, 2, 3. And 5s. Right there. And 5s comes next. So that's a pretty long electron configuration to start. We're really not going to go much further than the 5s. Okay, in college you will go further. You will do all of them. But this is just an introduction. So let's move down. Let's continue a little bit here. So that's the Aufbau principle. That's rule number 1. So electrons start at the bottom, at the 1s, and fill all the way to the top. So it's going to fill left to right. Okay, so we write this down on our paper, and I have a sheet that's going to have them written out for you, so you don't have to write all these lines out at first to begin with. All right, just practice. You can print it out and write it out on there. Okay, so now there's another term. The range of energy levels within a principal energy level can overlap. The energy levels of another principal energy level, for example, 4s, 3d, 4p. Now, this is telling us that the 3d is a very, very wide energy level, and actually it falls after the 4s. Okay, so 3d. I'm going to go back a slide just to show you. Your 3d is right here. Okay, here's your 3d. It comes after 4s. Why does it come after 4s? Well, you have your 3s, 3p. There's no more room in the third energy level. It pushes itself up into the fourth level. Okay, it's being pushed up. There's nowhere to go. Okay, cramming a lot of electrons in there. So this happens, and it's a very common occurrence. And it also happens with the 5s, 4d, and 5p. Okay, so just remember, 3d is after 4s all the time. Okay, you have to remember that. Okay, so here's the block that we talked about on the last presentation. Okay, just remember your S block is always here, your D block's here, and your P block's here. And you can clearly visibly see the 3D is right after the 4S. The 4D is right after the 5S. 5D is after the 6S, okay? Now, as you go left to right across the periodic table, you go through the different energy levels. So, the first energy level, you go across 1S, then into the 2S, then into the 2P, then into the 3S, into the 3P, down to the 4S, 3D, 4P, and then 5S, okay? Then into the 4D, but we're going to stop at the 5S, okay? So review that. Go left to right with this slide, and I have an attachment for you guys that you guys should look at, print out, or just keep it, review it. And this is found easily online. Okay, rule number 2 is Pauli exclusion principle. This means within one single individual line or orbital, okay, it may hold only 2 electrons, okay? One is going to have a positive or north spin, and the other is going to have a negative down spin, okay? One up, one down, okay? That was the easy rule. Rule number 3 is Hund's rule. This one's a little tricky to a lot of people, and this deals with, and I'm going to go over this a lot more in the part 2 video. Okay, Hund's rule is where electrons occupy orbitals of the same energy level or sublevel in a way that makes the number of electrons with the same spin direction as wide as possible. Okay, so if you're looking at a sublevel, like say the P, there's 3 orbitals. Each orbital must get 1 electron before it gets a second. So essentially you must go up, up, up before you give a down or a second to an individual orbital. Okay, so I type this up here. Working with one sublevel, S only has 1 line, so it doesn't really occur with that. P, D, and Fs are more important. At a time, each orbital must receive 1 up electron before it receives a second down. So picture you have your brothers and sisters, there's 3 of you. You have 2 other brothers or 2 other sisters. Your mom and dad have candy. To make it fair, if there's 4 pieces of candy, give each kid 1 piece of candy. All right? Instead of giving 2 to 1, 2 to the other, and then the third doesn't get any. You must spread the electrons out. That's essentially what we're doing. The electrons want to spread out as wide as possible to make it as stable as possible before it gets a second one. Okay, that's what you have to think about it. Very simple. Okay, so that's the end of part 1. Just also look in the book, review some of the information in there. This, like the things I just went over, aren't too crucial. But the most important thing is when you look across, go left to right across the periodic table, make sure you know what blocks you're going into and as well as the energy levels. That's the most important thing. So when you look at the periodic table, top left corner is the 1s. Then you go down to the 2s, to the 2p, 3s, 3p, 4s, okay? 3d, 4p, 5s. You need to know those orders by heart, especially if you're going to be taking college level chemistry. All right? Second nature. All right, guys. Take care.